Alright, hi guys and welcome. Today we'll be finishing up the pre-calculus series with the last theorem, which is the fundamental theorem of calculus. Now last time we did a definite integral, it took a long time. We did it as a summation. What we're going to do right now is tie together both the antiderivatives and the derivatives together, and we're going to tie together the idea of integrals together and be able to make something that just looks very nice, very neat, and a lot easier than the summation thing that we used for integration last time. So here it is. All right, and here it is. It is the integral from a to b of f of x with respect to dx. Okay, it is equal to the antiderivative with b plugged in minus the antiderivative of f with a plugged in. And it's that simple. It's something really nice. So a problem like what we had last time, I believe it was the integral from 0 to 2 of x squared dx. And if you remember, that took us forever to do last time. So what we're going to do is, here's how it actually works. What you do is you do the antiderivative. Okay, so that is going to be 1/3 times x cubed. Yep, that's right. Okay, and then I like to put, a lot of people put different ways of doing this. I put a little sign over here. This is just the way I learned from 2 to 0. This just reminds me of what numbers to plug in. Okay, so I do the antiderivative. Okay, and now I'm going to have 1/3 times 8, all right, minus 1/3 times 0 cubed. And if you're probably wondering where I got the 8 from, well, that's just basically 2 cubed. Okay, and I actually see a mistake I made here. Okay, let me see what 2. Yep. All right, so this is the function antiderivatized with respect to x, and I plugged in b, which was 2, so I just plugged in that. Okay, and then I just minus the derivative, or the antiderivative, when I plugged in a. And voila, you get 8/3 minus 0/3, which is just 8/3. A lot easier than the summation. Now, what this does is this actually ties together the idea of doing the infinite. And it just normally integration would take forever. But because of the fundamental theorem of calculus, where we actually tie in everything with displacement and velocity and everything, we're able to actually use this formula to make integration a lot easier than what it actually is. Okay, and just makes your job so much easier. And we actually found an error from the last one. I need to go back and change that in the other video, but that should be definitely 8/3. Okay. All right, so something that looks like this. This looks pretty hard at first, but remember, once again, we are just doing the integral, or the integral with respect to x, and we plug in b, and then we subtract it when we plug in a. Okay. All right, so we do the integral first. So we find the integral. So this should be 3/4, because I'm dividing by it, times x to the 4th. Okay, and then I also have my index. We call this an index in calculus. Okay. All right, so I do the first one, which is going to be 3/4 times x to the 4th, which would be 64. And then we minus, wait, hold on. That would be 4 to the 3rd. Sorry, 4 to the 4th is 256. 256. Okay, and then minus 3/4 times 1 to the 4th, which is just 1. Okay, let me see. 256 divided by 4. So obviously 64 times by 3. So we get 192 minus 3/4, which is going to be 191.25. And voila, we've actually found the area from 1 to 4, underneath from 1 to 4 of that. Okay, now if we wanted to do an indefinite integral, in other words, we're not finding the actual area under the curve, we're just trying to find the formula. Okay, let's say we had let's do 6x squared dx, something like that. Okay, so what I would actually do is this would become 2x to the third, because I'm going to divide by 3, because you do one above that, and then you just do a plus capital C, because we don't know about a constant possibly happening with that, okay? All right. Now, you're probably asking yourself, whoa, 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 the constant, oh, totally forgot about that. Where's the constant up here? Well, guess what? There's going to be a plus C here. There's going to be a plus C here. They're the same C, but if we're subtracting them, they both cancel out. It's really kind of cool. I'm sorry I forgot to talk about that in the beginning, but they usually just cancel out in the beginning, okay, when you do this stuff. But when you do the indefinite integral, you do need to just write out the formula and just have it as is, okay? All right. And the best thing about this is that sometimes you will be dealing with multiple ones. The rules still work for integrals as they usually do. Okay? All right. That is it. I'll talk to you later. Bye.